Hi, and thank you for your question. This is a great one on how to calculate the molecular formula when you are given the percent composition of an unknown compound. So in this example, we have the unknown compound X, and we know that its molar mass is 202.3 grams per mole. We're also given that it contains the element carbon and its percent composition is 95.02%. And we also know that it contains hydrogen and its composition is 4.98%. And those are the only two elements in the compound because when we add up the percentage, we get a total of 100%. So this compound is going to have the formula of CH, where we're trying to find the number of moles of carbon and the number of moles of hydrogen to create our molecular formula. So the exact number of moles of carbon and hydrogen and not the reduced form. So it's a molecular formula and not the empirical formula. So the first thing we're going to do is we need to know how much carbon makes up this total. So we know that 90% of, so if we're looking for the mass of carbon in our sample, and we know that it's going to be 95.02% of the total amount of compound X. So we're going to multiply the percent by the total amount to get the mass of carbon in the sample. So first of all, we need to change our percent to a decimal, times it by our total, and we get 192.16 grams of the compound X is going to be carbon. Next, we're going to do a conversion from grams to moles of carbon. So we're going from grams of carbon to moles of carbon. We're given 192.16 grams of carbon, and we want to convert that to moles of carbon. Those will cancel out, and that will give us moles of carbon. And we know that for every mole of carbon, we can find the molar mass, which is 12.01 grams of carbon in every mole of carbon. So basically, in this conversion, we're taking 192.16 and we're dividing by 12.01, and that's going to give us 16 moles of carbon. And then the next thing is we do the same process we did here, but now we do it for hydrogen. So grams of hydrogen is 4.98% of the total, which is going to be the same as saying 0.0498 times 202.3 grams per mole, which is equal to 10.07 grams of hydrogen. Divide that by the molar mass of hydrogen, which is 1.01 grams per mole, just because I'm running out of space, but I'm basically doing this same process here, and I get 10 mole of hydrogen. So using how many moles of carbon and how many moles of hydrogen, I get my molecular formula is C16H10. This is the molecular formula. If I wanted the empirical formula, I'd have to reduce these, and I would have 16 and 10. 2 goes into both of them, so it'd be 8 and 5 for the empirical most reduced form. So that's the empirical formula. But the question asked for the molecular, so that is the molecular formula. How it actually is when you find this compound in nature, it's going to have 16 carbon atoms to 10 hydrogen atoms. So I hope this helps. If you have any questions, just let me know. Bye for now.